Hey, it's Paul from howtonetwork.com. So in 60 days, CCNA in 60 days, version 4 is on Amazon if you want to check it out. Please like the video, subscribe and hit the bell to see all the other videos. So in 60 days, InterVLAN routing, which is day 21. As always, read the cram guide every day. Watch the videos from the day before if you can, and do the labs from the day before, and also today's labs and videos. There's an exam you can take online. Subnetting.org you can go to, or 101 Labs IP Subnetting the book. So today's InterVLAN routing, and also the lab to do for InterVLAN routing. There's some books that will help you. 101 Labs IP Subnetting from Zero to Guru, and obviously the 101 Labs Cisco CCNA book, lab workbook, which is currently on version 4. So that's all. We'll get onto the video and the lab. Thanks for watching. Welcome to the presentation on InterVLAN routing, or routing if you're in America. So as you know, we can use switches. We've already looked at the 2960. And these are very useful for creating VLANs on our network. And VLANs will give us more security, easier to administer, improve traffic throughput on our network, and a whole bunch of reasons to use VLANs. But one of the issues is VLAN is considered to be, or all hosts in a VLAN are considered to be on their own network. Now theoretically you could have a VLAN 10 and a VLAN 20 and all hosts could still be in the same subnet. However, they wouldn't be able to communicate because devices on separate VLANs can't communicate. Now you wouldn't really do that, but this just illustrates the point that devices in different VLANs cannot communicate. So there has to be some solution in order for devices on different subnets or different VLANs to be able to communicate. So first solution is to use router interfaces. For each VLAN that you have configured on your network, you add a interface, or you need an interface on your router. So we've got two VLANs on this particular switch. So in that instance, we need two interfaces, each one in a different subnet on our router, so we can route between the devices on the VLANs. Now obviously if you've got 40, 50, 60 VLANs, that means you need the same amount of Ethernet interfaces on your interface, which just really isn't practical. Now I've added a configuration here, and you're probably best off working from the slides if you actually want to try out these configurations, but we'll be doing some labs on these later. Now this particular solution we won't be doing. The reason is it's not something that's going to be tested, and it isn't really used, to be honest, because it's just not feasible. I've added the router configuration there. Next solution that is used is sub-interfaces. You've got one sub-interface, or a logical interface, per VLAN. So you could have 100 VLANs, for example, and you just create 100 sub-interfaces which are connected to a physical interface. So in this instance, we've got a fast Ethernet interface on our router, and we've actually configured two sub-interfaces, each on a different subnet, and each subnet is configured with a different VLAN. Obviously, if that interface goes down or there's a problem with the router, then you're going to lose connectivity. So here's a configuration I've put in again. You can either stop the slide or look at the download presentation slides. This is something that you may be expected to do in the exam. You've got the configuration for the router on the left and the configuration for the switch on the right. Basically, as you've probably already done, you create VLANs. If you have a multi-layer switch, you have to add the switch port command under the fast Ethernet interfaces, assign them to the VLAN, whichever one it is, and then designate them as access interfaces. Then you also need to create a trunk link with a switch port mode trunk and connect it to the router. The router has to be configured for trunking on the interface. With, on this particular example, it's .1Q, which is the only encapsulation you'll be tested on. So each subinterface is given an IP address also. Now I've added, just for your information, a management VLAN. This VLAN has been created as a native VLAN. This is also on the exam syllabus, creating a VLAN for security other than VLAN 1. So if you have a VLAN that isn't VLAN 1 on your switches, then you can create another VLAN on a sub-interface on your router. And finally, the preferred solution is to use switch virtual interfaces, which for InterVLAN routing, you're going to need a multi-layer switch. You can create switch virtual interfaces on your layer 2 switch if it's a 2960, but you can't actually do InterVLAN routing on it. So whether or not they'll ask you to configure a multi-layer switch in the exam, I don't really know, because what they say is the model tested is the 2960, which isn't a multi-layer switch, but they're asking about InterVLAN routing. So it's worth knowing this, and if you could get your hands on Packet Tracer, you can easily practice this lab. So we've got 3 VLANs, and just a configuration I've added here. Don't let it put you off, because I've actually configured a couple of VLANs here, so there's a bit of extra configuration, and several of the commands are under each interface. So because it's layer 3 switch, you indicate that it's a switch port after you've created the VLANs. Switch port mode access, switch port access, and then whichever VLAN number. And then you create switch virtual interfaces. So this is an IP address that's associated with any device that's connected to the VLAN. So I've got interface VLAN 10, which is the switch virtual interface, and I've added an IP address for that interface. For the host, you could add that as your default gateway because it's on the same subnet. One command I've added in red, which I've forgotten many times myself and may catch you out, is you need to enable IP routing on your layer 3 switch because it's turned off by default. If you want to create an actual layer 3 interface on a layer 3 switch, so you can just plug a device directly into it with an IP address, I've added the command here on the left, but I don't think that'll be something you'll be tested on. Alright, so we'll be doing some labs, so you get plenty of hands-on time. I've added them on the page that this presentation's on, and there's also some challenge labs later on. Welcome to our lab on InterVLAN routing with sub-interfaces. Got a switch in the middle. Our 2 top devices, the PCs, are going to be in VLAN 10. Our bottom 2 PCs are going to be in VLAN 20. I've actually used Packet Tracer for this because it's the easiest way and least messiest way of configuring everything. I've applied IP addresses to all of the PCs, as you can see, 10.10.10.10 and .11 on the right. Default gateway is 10.10.10.10 for the top 2 PCs and 10.20.20.20 for the bottom 2, or sorry, 10.20.20.1. So you'll need to add the IP addresses to your own PCs, and I've just brought up the interface now for the switch in the center. So go into configuration mode. I've obviously got to create the VLANs first. Create VLAN 10. I've given this a name. For the purposes of this lab, you don't really need to worry about it, but I've added a name here. Created VLAN 20. So VLAN 10 will be for the top 2 devices. VLAN 20 will be for the bottom 2 devices. I'm actually creating a third VLAN, which you don't need to do. It's VLAN 30. This is a management VLAN. I just want to do an illustrative point, which you'll see a line of config on the router in a moment, that if you have a management VLAN, your native VLAN, that's connecting through to the router, you need to inform the router what the native VLAN number is with a command. The reason is native VLAN traffic is not tagged, so it's telling the router not to tag the frames as they come in. So switch port access VLAN 10 for the interface range 1 to 2 drops those 2 ports into VLAN 10. And I've created I've added switch port mode access as a command to indicate that these are access ports. Interface range fast Ethernet 0/3 to 4, and switch port access VLAN 20 and switch port mode access to turn these ports into access ports. Now I'm going to connect to the router. Interface fast Ethernet 0/24 is what I've got connected, and I want this to be my trunk link. Obviously you're going to need a trunk link because you're passing more than one VLAN into the router. I've designated the switch port trunk native VLAN as VLAN 30. Again, it's not necessary for this lab, but I just thought it's important that you do understand this command. It's also asked as part of the security questions securing a switch, how to make a native VLAN other than VLAN 1. Now I've created interface VLAN 30 and I've added an IP address. So this is this is a switched virtual interface. We're actually doing an SVI lab after this one, because it's even though it's a virtual interface, you still need to no shut it. And then I've added an IP default gateway for the management VLAN, which is going to the router. Now it's time to configure the router. So fast Ethernet 0/24 on the switch is connected to fast Ethernet 0/0 on our router, and we're using sub interfaces as indicated in the lecture. This is obviously a tenuous situation. In case you do have an issue with the interface, then you're going to lose all of your sub interfaces. I've no shut fast Ethernet 0/0 and then fast Ethernet 0/0.10, which will be for our VLAN 10. Now on the more modern Cisco switches, including this one, the 2960, you only actually have one choice of encapsulation, which is .1Q. The other would be ISL, but it's been depreciated on Cisco devices. So typed encapsulation .1Q and then 10 afterwards indicates the VLAN ID. As an IP address, so the devices in VLAN 10 can connect to the router. So this is adding our layer 3 addressing now. Now we're going to take care of VLAN 20 with interface fast Ethernet 0/0.20. I've added an IP address. Now it looks like I actually did it in the wrong order. I should have put the encapsulation command in before I did the IP address, as it's given me an error message here. There you go, press the up arrow to get the previous command and hit enter. I'm just adding now the management sub-interface, so the traffic for the native VLAN can also be routed. Okay, so I've pinged one of the PCs just to test off IP connectivity from the router to the PC on the other end, and I've pinged one of the PCs that is attached to VLAN 20. So I'm happy there's IP connectivity from the router. Now I've connected to one of the PCs. I'll just type ipconfig just to see which one this is. Yeah, so it's IP address 10.10.10.10, so it's attached to VLAN 10 on the left hand side. I'm going to ping .11, which is on the same VLAN, which would work anyway because it doesn't go through the router. Don't need to route traffic on the same VLAN. Now we're going to send some traffic through the router so it can be switched between one VLAN, VLAN 10 to VLAN 20. Ping 10.20.20.20. So show MAC address table, we can see all the devices, or nearly all the devices. The PC connected to fast Ethernet 0/4 isn't in the MAC address table. The reason is no frames have left the PC or been sent to the PC. So just to demonstrate, I'll do a ping or issue a ping from the final PC. Ping a device on VLAN 10. And now the MAC address table should be populated. Just hit the up arrow, show MAC address table, and you can see the device connected to fast Ethernet 0/4 is now populated there. So you can see how we're using layer 2 and layer 3 together for this lab. Just issued to show VLAN brief, although it's not strictly a VLAN's lab. So you can see which devices are connected to which VLANs. Welcome to the Switch Virtual Interface Lab. We're using Switch Virtual Interfaces for our InterVLAN routing. You can see the gateways we have for VLAN 10, which we're going to be dropping our PCs in, and VLAN 20 on the bottom. We're using Packet Tracer again, and in the middle we've got our multi-layer switch because I wanted to demonstrate some commands that you would be using on a multi-layer switch. You shouldn't be tested on multi-layer switches in the CCNA exam because it's not in the syllabus. However, then Cisco do reserve the right to ask you whatever they feel like asking in the exam if you check their terms and conditions. So I've logged onto the command line for our multi-layer switch. So this is layer 3 capability as well as your layer 2, which you get with your 2960. So 3560 model. Now, the commands that you're going to be configuring here will look familiar, but then there's another line that you have to enter because it's a layer 3 switch. So I'm creating VLAN 10 and I've just created VLAN 20 also. Exit out of there and I use the interface range macro to save a lot of time and typing. Very handy command this. And I have to add the switch port command, which is designated to the switch that this is used as a layer 2 interface. If I wanted to use it as a layer 3 interface and actually put an IP address on it, I could. I would type the no switch port command, press enter and then type an IP address. Indicated it's an access port and I want it to be in VLAN 10. Or both ports to be in VLAN 10. I'm going to do the same thing now with Fast Ethernet 3 to 4, but this will be in VLAN 20. Now obviously we've enabled the layer 2 part of the configuration now, but the two VLANs still need a layer 3 capability in order to speak to one another, and this is where our switch virtual interfaces will come in. I've typed interface VLAN 10 and added an IP address to this switched virtual interface. So you can't actually point to it or see it anywhere on the switch, but it does exist on the switch configuration. Now for VLAN 10 I need to choose an IP address in the same subnet as the hosts that are in VLAN 10, and the same for VLAN 20. And then the layer 3 capabilities of the switch will enable the routing, the layer 3 communication between the two VLANs. Now I have missed a command off here, which I'll demonstrate when we can't get a ping to work between the two VLANs. I'll demonstrate why that happened and what we need to add. Show VLAN brief will show us the two VLANs that have been configured and which ports are in those VLANs. Show IP interface brief will show us all our Fast Ethernet interfaces, and then also when I press the spacebar we'll see our two switch virtual interfaces here. Alright, so I'm on PC 0, which is 10.10.10.10 I believe. And I'm going to ping the next door PC on the same VLAN, which as long as our layer 2 switching functionality is working, which it is, you can see that's worked correctly. But now I'm going to ping across the VLAN from VLAN 10 to a device on VLAN 20 and it won't work. Now, this is a command I mentioned was missing off the layer 3 switch, the multi-layer switch. And it's easy to miss this command off because it's on by default on routers, which we probably spend more time configuring, and the command is IP routing. So this enables layer 3 capability on our multi-layer switch. Now when I go back to the PC and ping across the VLAN, it should work. Now I recommend you do this lab, same with all the other labs, over and over and over again until you're comfortable with all the configuration commands.